Hello everyone and welcome back to another video. Today I shall register number URK20CS3026. I'm going to explain to you experiment number 9 of operating systems lab. So today we will be doing file management system. So our aim is to implement file management system in 3 different ways. That is, first, contiguous memory allocation, second one is linked list memory allocation, and the third one is finally indexed memory allocation. So in contiguous, basically the memory blocks are arranged one after the other in a continuous order. That is how the memory is allocated at first, and then the blocks are allocated accordingly in the same continuous order in that memory. And then in linked, what happens is wherever it finds free space, it will allocate the blocks and it will link a certain block to the next block and so on, and it will place it at random locations. It doesn't have to be like in a continuous order, so if there are any occupied blocks in between also, it can place few of the blocks on one side of the occupied block and link it to the other side to some other places where there are unoccupied spaces and so on. Indexed, it doesn't have to be like at one place, or neither it has to be linked. Instead of linking, what happens in index is there will be a block. In that block we will be saving the addresses of all the different blocks where all we have saved our data. So finally we will be running all these 3 different functions using a menu driven function. So let's see the first contiguous memory allocation. I'll explain the code. So as you can see, we are taking the input of how many memory blocks are needed. We are creating a memory using a list, and initially we are setting all to false because we want to see that the memory is empty. For that we signify it using false for n, like n entries of false, and after that we ask what all blocks or indexes should be occupied, like which all could be occupied in the memory, and for those indexes we will be setting memory as true. And later we ask the files that we need to save in the memory and the file sizes of each of those files. And after that, m is length of files, and we create a allocated list in which we'll be having the starting indexes of where all we have saved our files. So basically for all the files in m, and in that we'll be running it for all the spaces of the memory for each of the files we will be checking. If like initially, if not in the memory and count is lesser than size, so when we are allocating the first block, in that case we'll be incrementing count and size till the time we allocate the first block, and when count is equal to size, that is the first block memory allocation has been done. In that case we'll be going in reverse order from I minus 1, that is the last block. When we allocate, after that it will go to the next index, but we want to allocate one index before that because that is where the first block ends. So from there till the beginning, that is I minus 1 size of j, we'll be going in minus 1 increments, that is it will be decrementing by 1, and we'll be going till the 0th index. So that will be for the first block, and we'll be setting the memory as true, and allocated we'll be setting as the 0th index because there is where we start. And for all the other ones, initially this count will be lesser than size of j, so we'll be breaking this loop, but at the same time we'll be able to increment till the free available memory using this else statement. And whenever it increments, if n it is equal to n, in that case our memory has got full, so it will be able to break only. Else, in the case that there is memory available, so wherever the memory is free, there we will be going back to like the beginning again, the while loop itself. For I again will be incremented, and there we will be checking since memory is available and if the count is able to fit the size. In that case we will be getting again count is equal to size of j, and we will be allocating that second file also, or third file, and so on, nth file, and we will be continuing the same process. Finally we print out the output that in this manner, that if allocated of j is none, in that case we will be saying that it is not allocated none, and else we will be printing that the string allocated where it starts, and then what all are there, like in the range of what all blocks are allocated for that string, all of that we will be printing. Then for linked, when we see over here, we take the same memory parameters, but here the difference is here each allocated will be an array in which we will be having lists inside the allocated array itself. So for each of the files, what we do is in this allocated we will be saving exactly where we are storing each of the indexes. And like the previous one itself, when count is lesser than size, it is not in the memory. like memory is empty, in that case we'll be appending that index to our allocated of j, that is the j list inside the allocated matrix. We'll be setting memory of I is equal to true for all the indexes that we assign. We increment count by 1, I by 1, and from the second, third, fourth, the nth file except the first file, we will be running this also. So that because initially the memory will be occupied by something else, or initial indexes which have been linked here and there, all those linked indexes, because it's going in the order, so that's why the initial indexes which were free will be allocated in the linked manner, and then from wherever it is empty, from that link it will be again checking whether there will be empty spaces available to fit the next file, and if that is possible, count is lesser than size, we get that, again we will be allocating the next file, and so on. And lastly, if I is like n minus 2, in that case we will be breaking, because, or I is equal to n, in that case also we will be breaking, because it has reached the end of the index, and memory space, we don't have any more memory, we cannot allocate. And then finally the output also we print in this fashionable manner, same like the first one. Only difference is, instead of range we'll be having like a range of, in that allocated we would be printing the values in between, but here where all we have randomly allocated the linked blocks, all those randomly allocated linked blocks will be printed out and starting index. Then in index what happens is, we'll be taking the input as usual, and like similarly linked only, we'll be having a matrix over here with m number of lists, in which we'll be storing for each job, and each of the jobs is allocated to each list, like each of the indexes of the job is allocated to each list. And here also, wherever we get free memory, similar to the linked list one itself, it will be allocated in each and every free memory. And finally the index will be allocated, like the all the allocated list will be allocated to the index of where the index of the starting block is. And finally we print out the output, that is if allocated is empty matrix, in that case we will be saying that we have not assigned any blocks, else we will be showing what has been allocated. And finally we will be showing the driver, that is in this we will be running the 3 functions as previously mentioned, and the outputs are as follows. So I will given some sample inputs over here. As you can see, initially itself, like in contiguous it will be one after the other, in a continuous manner it will be allocated. So if there is any gap in between, like maybe the 4th index, and only after those indexes can we assign something, like in the 6th index occupied, so in that case they could only use from the 7th index whatever they had to fill. And similarly, that's why 5th index got filled for a process that came after the D process, but D process got a later space because it needed more memory. Similarly here, in linked allocation, you don't need a specific kind of memory space. You can just fill in empty memory spaces and it will get a link attached. So like 9, 11, here 10 has already been occupied. Similarly 4 over here has been occupied, and 18 is occupied but it is not used. So 4 and without 4 and 10 in between the list also, it has been able to omit those spaces and link 9 and 11 and 3 and 5 and so on. And that's why it has been able to allocate the memory blocks like that. And in index, at every index block we have been able to save the indexes of all the other blocks of the file. So all those block file indexes have been stored in the index table at index 2, index 10, index 12 and index 7. And finally the 4th option we can exit. So that was all for experiment number 9. Hope you liked this video. If you did, do give it a like and do subscribe to my channel for more such interesting videos, and see you guys in the next one.